Hello, this is the luckiest maths teacher in the world. So last time we looked at Pythagoras Theorem and finding the length of the hypotenuse, which is the longer side. Now we're going to look at using Pythagoras Theorem to find shorter sides. So Pythagoras Theorem is all about right-angled triangles. So we're still using the same type of triangles, right-angled triangles. Now this side here is still called the hypotenuse and the longer side. But now what we're going to do is find one of the shorter sides. Now it is the same formula that we use. So remember, we call the two shorter sides A and B. It doesn't matter which way around. The hypotenuse C. And Pythagoras theorem is A squared plus B squared equals C squared. So if I want to find the length of a shorter side, I can rearrange this equation here. So what I can do is I can subtract B squared from both sides. So A squared equals C squared minus B squared. And then if I square root each side, I get A equals the square root of C squared minus B squared, okay? So this is an important point. Now, when we were finding the length of the hypotenuse, there was a plus inside the square root. Here it is a minus. So we are subtracting, and it has to be the shorter side from the longer side. So we can use this formula to find the length of a shorter side. So let's look at an example. So let's say I have this right-angled triangle here. So let's say that this side here is, say, 24. This side here, I don't know. And this side here is 25. So I want to find the length of the unknown side. Now, even though this formula here says A equals blah, 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 it doesn't have to be A. It could be any letter. I can call the side I want to find X, Y, Z, whatever I want. So I'll just call it X here. So the length of that side would be the square root of longer side squared minus shorter side squared. Now you can put that straight on your calculator. You probably need to put this part in brackets just to make sure you're square rooting the whole thing. And the answer you should get is 7 units. Again, if the other two units were, say, in meters, then the answer would be 7 meters. So, easy as that, that's how we find shorter sides. So, I'm going to clear this and do a couple more examples. Please copy this down if you need it. Okay, so let's say we have another right-angled triangle here, and I wish to find out what this length is, B. So, again, it doesn't matter what letter I call it, the way I find it is the same way. It's the square root of longer side squared minus one of the shorter side squared. You put that straight on your calculator. Now this one doesn't give you a whole number, so if you're asked to give it as an exact value, this is exact square root of 68. It has a decimal expansion that goes on forever. And so sometimes I might tell you to round the answer, so that is 8.25 to 2 decimal places. Okay, so that is a rounded answer. It's not an exact answer. All right, so we'll do just one more question that is worded this time. So let's have a go at this question here. A square has diagonals of 10 centimeters. What's the side length to 3 decimal places? So if we are given a worded question like that without a diagram, first what we need to do is draw a diagram. So I'm going to draw a square now. So that square, we're told, has diagonals that have a length of 10 centimeters. So the diagonals are this, okay? So that there is 10 centimeters long. Now, I know that this is a right angle because it's a square, so I can use Pythagoras. Now here the question's a little bit different because I do want to find a shorter side, but the problem is I don't know the other shorter side. But these two sides must be equal, and these sides are equal too because it's a square. So I'm going to let this side be A. Now it turns out that I can use Pythagoras theorem if I know the hypotenuse to find the lengths of the shorter sides in a right-angled isosceles triangle. So this triangle here is right-angled, but it's also isosceles because two sides are equal. So that means that this angle here will end up being 45 degrees. So what I'm going to do is I'm going to form an equation. So I know that Pythagoras theorem is that the sum of the squares of the two shorter sides So this is one shorter side, another shorter side, equals the square of the longer side. So a squared plus a squared equals 10 squared. So I want to find what a is. A is the length of the side of the square. So a squared plus a squared equals 2a squared. 10 squared is 100. So then I divide each side by 2. Then I get a squared equals 50. So a is just going to be the square root of 50. Again, that is the exact value. So if the question said give your answer in exact form, then we're done. And if we had to round it, we just put square root of 50 on our calculator, and the answer to get to 3 decimal places is 7.071. So that's to 3 decimal places. So this is the process you use when you have a right-angled isosceles triangle. You know the hypotenuse and you want to find the length of the shorter two sides. I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.